This conference will now be recorded.
Hi, a very good morning to all of you. Am I audible? A very good morning to all of you who have joined for this session. I am Rehna Bivi, Project Officer at Energy Efficient Building Cell at EMC Kerala. I invite Mr. Thompson Sebastian, Energy Technologist, Energy Management Center Kerala, for the introductory remarks. Welcome all the participants for the two-day webinar on energy simulation. Over to you, Thompson.
Good morning, all. On behalf of EMC Kerala, I welcome all of you to this two-day webinar on energy simulation. Today, the NSR is on other meetings. That's why I came here to have this introductory remarks. So today we are having Mr. Kumar Biplab, ECPC Master Trainer. He is well versed in energy simulation and this kind of stuff. Actually, he is whenever we need a detailed webinar or training session on ECBC, our first choice is Mr. Kumar Biplab. He is such a good person in terms of this energy simulation and everything. So he will cover all the things related to this ECBC energy simulation and everything in these 2 days. Once again, I welcome Mr. Kumar Biplab to this two-day webinar session. Lehana will give a brief introduction about him. Once again, I welcome all of you to this two-day webinar and make this webinar session a fruitful session. Okay, thank you.
Thank you, Thompson. As Thompson said, it's a privilege for us to have Mr. Kumar Biplab as our master trainer. He has more than 10 years of experience in energy audits, retro commissioning, project management, etc. Currently, he is working as the Vice President of Engineering at Livolt LLC, and he is also the founder and principal consultant of Kumar and Associates. He is a mechanical engineer and a postgraduate in energy and environment from IIT Delhi. I welcome Mr. Kumar Biplab to the webinar. Over to you, sir.
Thank you so much. Very good morning to everybody. And today we'll learn about eQuest, one of the software that we use for energy simulation. And give me 1 minute. I'm just going to share my screen in some time. So we'll learn in detail regarding not only energy simulation, but also a few details about air conditioning and how you integrate air conditioning and other things into the energy simulation software. Okay, so the way that I want to take this through is basically I will be taking you through the entire software, and all you have to do is probably sit back and just watch the steps. And since this video is being recorded, and I hope the recording will also be shared later on, you can always go back and try the same steps later on your own PC. For now, I think you should just sit back, relax, and just watch what I'm doing. So we'll start with a basic introduction of energy simulation. In fact, what we are trying to do. In fact, I will probably use Word file and of course, if you have any minor comments, you can always type it in the chat box. All right. So I hope my screen is visible. I'll zoom this even further. Now, the first basic things that we are looking at is what is energy simulation and what we are doing over here. Now, any equipment, or I would say any electrical equipment, they consume energy, or in fact, they need electricity to produce some kind of output, right? So the output is either mechanical or some other kind. As you may be aware of Newton's law, energy can neither be created nor destroyed. So whatever you input, some part is gone into losses and the rest is in some kind of work. So for example, a light, when we say 10-watt light, okay, so what does this mean? This means that the light, or let's say light bulb, the light bulb needs 10 joules. You may be aware, joules is a measure of energy every second to produce light. Okay, some amount goes to heat, everything else is converted into light. So this is the basic thing. When we say 10-watt light bulb, it requires 10 joules every second to produce light. Similarly, every other equipment, you have mobile chargers. When you're charging, you might have heard about 18-watt or 15-watt fast charging. That means that it will draw 15 watt of power and it will power. So this watts, or the symbol is watt, is unit of power and also called as demand load. Okay. So what is the demand? That is what we are measuring. And when, let's say, this 10-watt, when in fact I'll say 1 kilowatt, which is nothing but 1000 watts, is run for 1 hour. Okay, we get 1 kilowatt hour, which is 1 unit of electricity, and kilowatt hour is measure of energy. We call it energy consumption, right? So two main things: demand load and energy consumption. Okay, two things you must be very clear about. And with this in mind, just like lights, we have our air conditioning, which takes energy. So what we try to figure out in energy simulation, when we say about energy simulation, we want to find out, one is energy consumption, and the second is what is the demand. So these are our two goals, and especially for buildings where there is a lot of interaction between air conditioning, heating, and heating not so much in many over here in India, but few places in Northeast and Kashmir maybe. And then you have ventilation and lights and every other piece of equipment within a building. Okay, so what we are trying to find out is uh, give me 1 second.
No, sir.
Hello, Kumar sir. We can't hear you. No, sir. You are not audible.
Okay, I believe I'm audible now. Okay, not sure what happened, but probably I had muted the call for a minute, and after that it was not getting unmuted. So sorry, apologies for that. Um, okay, give me 1 minute. All right. So I'll probably just repeat what I said over here. The last part, I think that is what everyone missed. So there are various softwares which we use for finding out the energy consumption as well as the demand load. Now, some of those softwares are eQuest, which is very easy to learn. Then we have Open Studio, Energy Plus, IESVE, and Design Builder. So IESVE, Design Builder, they're all paid softwares, but our focus is on eQuest, which is very simple to learn. So with that, we were talking about heat loads. In fact, I have not even started heat loads. So when we talk about heat loads, it's basically about how much heat that is coming in to the building. That's what we would like to know. And that depends, the amount of heat that's coming in, that depends on a couple of factors. One is, in fact, location of building. Okay. So that is we call weather data. Right? First and foremost, that will determine our heat loads. Next is the building geometry. So for example, if there are shades on a window and the location of the window, so that also has a play on the heat load. So for example, a west facing window will have higher heat load as compared to a north facing window. Then we have construction materials. Okay, so construction materials, what we are mainly looking for is roof construction materials, in fact, of, I would say, envelope. So that means you have roof, wall, and windows. So those are the three items that you are looking at most of the time when you are trying to determine the heat load, right? So once you have the heat loads, what is the next thing that you want to do is you want to calculate the internal loads. In fact, heat load, we'll call this as heat loads external. Okay, so this is external to the building, and the next is heat loads internal. So by internal, we have your lights. So light bulbs also give out some amount of heat. So LED, for example, it will only give out 20% of the input power as heat. So if I say 20% in the example above, where we had 10 watt of light bulb, that means 9 watt will be used to produce light and another 2 watt will go into heat. So that's the internal heat load. Number one is lights, number two is occupancy, Number 3 is any miscellaneous equipment. For example, you have computers, printers. Now these also give off heat. Right. And for all of these, the most and critical thing is the schedules. Right. So what time the office starts, what time the office ends. Based on that, your light patterns will vary, your office patterns will vary. The now take for example a hospital with 24 hours or with just an OPD. So everywhere the schedules will vary, and these schedules have been standardized. For example, an office building, daytime office building, will say it is from 9 to 5, and it's a standard. It has already been provided in the ECBC, in the national ECBC, which you can always download and check. Right. And one more factor is infiltration. Okay, so how much amount of outside? So infiltration can sometimes be classified under external, sometimes it can be classified under internal. So that's there's no hard and fast rule. But for example, if there is any leakage from the windows, so that we call it as infiltration. Or there is a leakage from the doors, that will be counted in. Right. The next thing that we'll do is after this, when you're done with the heat loads, now we have to figure out what we are doing with the air conditioning. Right. So what the air conditioning does is it sums up all the external and internal loads, and the air conditioning will try to throw out that heat outside to the building. And that is why you must have seen in the AC, when you go out to the outdoor unit, you'll find hot air is coming out. So what the air conditioning is doing is it is taking all the heat from inside and throwing it out. So that is the job of air conditioning. Okay, so air conditioning, we provide all the equipment, and because it consumes electricity, the software will find out for us how much electricity is being consumed by the air conditioning. Okay, so these are the major things that will go into your eQuest software. If you understand the overview, after that, in the next 2 days, what we do will be very simple for you. We are going to do these exact same things in the software. Okay, so we'll be entering the location, that is the weather data. We'll be building the geometry. We'll be inputting the construction materials, and then we'll be inputting lights, occupancy, equipment, and schedules, and the infiltration rates, and finally the air conditioning equipment. And once you do that, the resultant is annual energy consumption. So what do we mean by annual energy consumption? It means that over the entire year, what will be our energy consumption? Okay. Another thing that we also look at is your comfort. Okay. So if you undersize the air conditioning equipment, then you will feel uncomfortable, and that is something that the software will also give us as an output. So for example, if you have given a set point of 25 degrees Celsius in your room, and let's say any 1 hour the temperature in the room, because the heat outside was so high, the existing air conditioning equipment could not maintain that at 25, and the current space temperature was 26 degrees Celsius. So that's 1 hour of uncomfort or unmet hours. So we'll talk about that when we see the results in more detailed fashion. So with this in mind, if you have any questions, I hope you got an overview of what we are trying to do. And if yes, then probably we can proceed to learning the software. If no, or if you have any specific queries, you can ask me now. In another 1 or 2 minutes, I can probably address the questions. So yeah, in the chat box, you may please go ahead and ask any queries. So I'll probably wait a minute or so if there are any questions. Otherwise, I'll probably move ahead. Okay, so I think no questions, so we'll move ahead. Okay, the first thing that we need is when we are trying to build a 3D model in eQuest is your plan of the building. So I don't have a plan as of now, but let's just assume that you got a plan in AutoCAD, a CAD drawing. Let me pull up if I have some old drawings. Let me just give me 1 minute. I'll pull up an old drawing in which I can show you what we are trying to do when we build the model. So give me 1 minute. I'll just have a quick look. Okay, so I think I have something here. Right, so this is a very small building that I have taken up. If you can see the plan, so we have 2 labs and just 4 classrooms. Let's say it's a kindergarten, and it's I would say 4 stories tall. Okay, and daylight. Okay, so this is the original drawing where you see these are walls and you have windows. Okay, so and 4 classrooms. The first and foremost thing that we will do when we try to build a model in eQuest and when we get this AutoCAD drawing is to prepare an SLD. That SLD, we call it a single line diagram, and that single line diagram is actually built on the innermost side of the wall, of the external wall. Okay, you build that out, and when it comes to internal wall, you can either draw it on the left side or on the right side. It's completely up to you. It doesn't matter too much. But when it comes to the external wall, you have to build your SLD on the inner side of the external wall. Okay. And then we also give certain lines wherever the windows are placed. So I just had switched off the layers. So if I look at the SLD, you can see that it is on the inner side of the external wall, and I've drawn two projections for demarcating the windows. Okay, and when we are demarcating the windows, we are only demarcating the external windows. We are not demarcating the internal windows or doors. Okay. With that, the next thing that I would do is copy just the single line diagram into a separate file. So which I already have over here. 1 second. Okay, yeah. So as you can see, I have built out the same yeah, as you can see, the same SLD we have copied into a separate file where we have just this one thing, and we have brought it down to, in fact, we have moved that entire SLD to 0, 0. Okay. Now we'll be using this single line diagram to build out our model. Right. So we open eQuest. So I'll create a new project. Here I prefer going into design development wizard. That's easier compared to the schematic design wizard. Let's rename this as school project. Say 1. Building type you can choose. So what happens is when you choose the specific building type, it automatically populates the different schedules, which you can further modify as per our ECBC. So this will be school, let's say K6 to elementary, and location, yes. Which software is simple and easy for simulation that you are learning? eQuest is the most simple software, and it's the easiest, and it's free. Okay, so a little bit about the weather file. Weather file is provided by ISHRE, which is Indian Society for Heating, Refrigeration, Air Conditioning Engineers. And for eQuest, we use either bin or .binm files, the extension, the file name extension. If I just show you the location from where you can actually search for the weather file. is this search ISH ISHRE weather data. So if you do a Google search, you'll find that the first search result is the select ISHRE weather files, white box technologies. You can go there and there are 62 total number of weather locations. You can straight away just select whichever one you want. For example, if there's one for Thiruvananthapuram, you can click that and you can proceed to check out. You enter all these details and you continue checkout and it will be downloaded. The file location should be in C drive. Let's go to under, in fact, if you just click on documents on the left under quick access, if you click on documents, you'll see something called as data. Okay, so whichever file you have downloaded, that is equest, whichever version I mean. So if you have downloaded the latest version, you will find out that it is 3-65-7175. Go into data and go into weather and just place the bin.m file. As you can see, you'll have the bin.m file. You see the file extension .binm. That file will be downloaded. Copy that and paste it over here. And if you click here, press Ctrl C, and you choose the weather file from this location. Paste on the top, press enter, and there you have it. Okay, so okay, if it doesn't show up over here, see, you have .bin file, for example, over here. Oops. I suspect this is this one. Let's look at Thiruvananthapuram. Okay, there you go. Now, the thing that we could not find was the bin.m file. Doesn't matter. All you have to do is, let's say I want to use this one. I'll copy this, go into this one, weather, and paste it here. It says there's already a file in there. I'll just replace it and I'll copy this entire file name. Right, I copied the entire file name along with the extension, went here, all I did was paste, Control V. Okay, so as you can see, .binm has been pasted over here. So this will use the latest file. Bin.m are the latest files released by ISHRE. And that's that really. Okay, so now you have selected the location. You go to next, and of course there are, as you can see, it automatically determines the season when the school is in sessions, when there is a break. For our purposes, for the purposes of ECBC, it says that you don't take into consideration the breaks. If you look at the ECBC schedule, it will give you an annual schedule. So what we'll do is we'll just use a single number of sessions. The observed holidays will uncheck because these are as per US. We'll just uncheck everything. Go to next screen and continue to navigate. Right. Just 1 minute. All right. So this is the project navigator window, and this is where most of the things that we do. And in fact, this is, as you can see, design development wizard. So this is basically a wizard mode. So wizard mode, wizard modes in eQuest. One is wizard mode, and the other is detailed mode. And when we are using wizard, it really helps us to just make a bridge to the detailed mode. Okay. And we just came from this, the first one. Okay, the project site and utility. If I go to previous screen, you can see these were the ones which we did, and you can, if you want, you can replace the weather file. If you selected a wrong file, you can just, and you click on return to navigator. So that's project site and or utility. Okay. Next, the thing that we want to do is import the single line diagram we had previously created. We click on edit selected shell. Right? Ignore whatever building shell area has been provided. Let's say we'll have one floor like this, and in the second floor, just above, what we'll do is we'll probably remove the windows in the labs. So on the ground floor, we'll have windows, and on the first floor, we will not have windows. So we'll see how we can utilize the same drawing, or if you want, you can use different drawings and create floors one above another. So we'll say number of floors above grade is just one, because we are currently building the ground floor. Go to next screen. By default, it assumes some share, but what we are going to do really is import our CAD file. So what we'll do is we'll select custom, and we'll say we are starting with a blank slate. And here, as you can see, we can import our CAD file. Click on OK. I'll copy the location in it. And here, of course, forgot to mention, you have to create DXF files and not DWG files. So I'll use that and I'll click on open. The next thing is you have to specify what is the actual units of measurement in your base file, that is the SLD. So if I say it is 1 unit is 1 meter, for example, if I measure the distance over here, it is 2.4. So 1 unit over here is in the CAD file is 1 meter. So 2.4 meters in width. So what I'll say is 1 CAD unit, and I'll check here I have meters. Okay, so 1 CAD unit equal to 1 meters. Had it been in mm, all you have to do was type in 0.001. Had it been in millimeters, but since our drawing is in meters, I'll leave that as is, and the base point will leave it at default because I've already brought our drawing to 0, 0. So what is generally suggested is, let's say you have a very big building, there will be either a lift or a stair somewhere, which is common throughout the building, because different floors have different configuration. They may vary in their entire footprint. So it's always recommended you bring the staircase or a lift, which is common throughout that point, to the origin. Okay, I'll click on apply, I'll click on close, and as you can see, I have my SLD over here. The next things that we are going to do is critical. Here I right click and click on view properties, right? And I'll uncheck show grid and make this grid resolution as 100 feet. I'll change this CAD vertices and polygon vertices. This is the snap range to 1 and 1 feet. For snap, I'll put CAD as first, polygon as second, and grid as no snap. So this will help me in defining the footprint. So here we're going to do two things. First is define the footprint of the entire building. Okay. And the next thing we are going to create is individual spaces. And we'll go anti-clockwise. So I left click, single left mouse button click on the first point. Okay, it shows a point in light blue color. Then keeping my left mouse button clicked, I drag it and release my left mouse button at the second point. Similarly, I drag it and leave my left mouse button on, and it creates at the third vertex. It creates a vertex. As you can see here, the XY coordinates of the vertices are created. Now let's say you made a mistake somewhere. Let's say this is the fourth point, and let's say I wanted my fifth point to be here and not here. Okay. So in that case, how do I move this point? A single left mouse button click turns the color of that dot from light blue to creamish color. What this indicates is now this vertex is in move mode and not create vertex mode. So as you can see, I can move around this and put it here. And then again a single left mouse button click and I move to the next point. Okay. So my footprint shape is now complete. Now all I have to do is create thermal zones. So I'll click on done, click on yes, and then as you can see over here, zoning pattern, I'll say custom. Again, choose the blank slate. I'll use the same CAD file which has already been imported and click on. Now here I'll create each specific rooms. So the snap should be in when you're creating the points, it should be in anti-clockwise direction. And whenever you go, the first thing that you need to do is right click somewhere outside and click on view properties, and there make sure that you have grid resolution as 100 feet CAD vertices as 1 feet and polygon vertices as 1 feet, which is the snap range, and then the snap priority. So that means which item should it choose, the CAD drawing first or the polygon or the grid? So you have to define this first, second, and third. So we always prefer the CAD to be the first, the polygon to be the second, and grid should be no snap, right? So I hope that explains Rohit's question. So click on done, and then you have to draw the points in anti-clockwise direction. And then when I am doing this, I can, if you want to zoom in, right click and zoom, right click and fan. You can do all of that. And when you want to create, you must be in select mode. So click on the first point, then the same, having your left mouse button clicked, drag to the second point and leave your left mouse button. And when you're creating the zones, we really want to have the windows also. The reason being, it will be very difficult later on just to figure out where to put the windows. So if we do it right now, we had our markers which indicated the windows. So it will be easier for us to create the windows. Oops. So as you can see, this was in move mode. So we'll undo. And of course, one more thing is please keep your hand away from escape button. I know some of you may be architects, civil engineers, and using AutoCAD, the first item is, your hand remains on escape button. Don't hit escape button. Okay, leave your left hand or right hand, whichever one, or away from escape button. If you press escape, it will vanish. This window can vanish, and you can lose all the changes. So that's that. Now you have created your first zone, okay, which is a classroom. We'll create next zone. If we want to create next zone, we'll click on create new zone, and then this will be turned into green. Again, the same thing. Yeah. Next, create new zone. This turned green. Try to put all the conditioned zones try to create the conditioned zones first and then the unconditioned. So for our purposes, we'll say that the corridor is unconditioned and the classrooms are conditioned. Create new zone. Okay. And this one. Create new zone. So if you remember, on ground floor, we had said that there will be windows in the labs, but not on the first floor. So we'll create these windows. Create new zone. And remember, again, once again, it has to be in anti-clockwise direction. You can see I'm moving, I'm creating all my points in anti-clockwise direction. And you may question why. Well, that's one of the rules of equest. That's how you do this. And finally, we have our corridor. Okay, if I zoom out a little, there you go. And once you have created the last zone, don't click again on create new zone. You just finished. You unselect, and if you want to make changes in any other zone that you have created, you can straight away just click on that zone and make any changes you want by either moving the points or typing it over here manually. You can type out the coordinates over here manually. Okay, let's click on done. Now if you see over here, it tells you about the area. So you can see over here, this is 7,220 square foot approximately over here. Next, we define our floor to floor height and floor to ceiling height. Ideally, I would suggest that you keep the floor to floor height and floor to ceiling height the same. But if you want to create, you can go ahead and create. The only thing is a few more zones will be created. That is the ceiling zone will be created for each space. So just to have a simplicity, we suggest make the floor to floor height similar to floor to ceiling height. Right. So let's say it is 12 feet and 12 feet. This is done. Don't worry about the directions right now. We can do that in detailed mode. So if we go back to our, we did location, building geometry. We have not completed it fully. We are in the process of doing it. Go to next screen. Now here, this is just a wizard mode, wherein it tells you what are the different type of surfaces you can choose. Now, if I remember, I had told you earlier that there is a floor above. So technically, this is, as you can see, this talks about building envelope construction. So technically, there is no roof. It's just a floor above. So what we'll say is no exterior exposure, right? Then above grade walls, you can either create your own construction over here, or you can wait to go to the detailed mode to create your detailed construction. So here, let's say it's a brick wall. And you can select the category. For example, from the outside, you have to define the wall from the outside to the inside. So you have, first of all, is plaster. Say cement mortar. Yeah, 1 inch of cement mortar. That's fine. Then we'll go for brick. Okay, let's say 8-inch brick. And finally, again, a cement mortar of 1 inch. And you can say this is vertical exterior wall, right? We'll learn about what you see over here, the R value or the U value. We'll learn shortly. But for now, you can just create this and click on done, right? And the ground floor will be, as usual, it is exposure to earth. It is in direct earth contact, and the construction is 6-inch concrete. Infiltration shell tightness, you can leave it at default. So now you have defined just the wall construction. The roof construction we're going to define when we build the topmost floor. So click on next, and here we'll say there's no so this is about the interior constructions. So interior finish, just say none, no ceilings, and we'll say there's no wall insulation. Okay, so this is hypothetically we are creating a scenario where we are trying to build a very simple building, which we usually see. Okay, and let's ignore the doors for now. If there is a glass door, you can go ahead and build that. But if there's just wooden door, probably just go ahead and ignore that. So let's say this is a glass door, and I would say one on the east side. In fact, let's look at over here. The first thing that we missed was also where is the north direction. Let's say, let me draw the north over here. Oops. Switch off ortho and some angle, let's say. This is my north direction. So which is at an angle of 43 degree, right? 43 degree from horizontal. So we'll look at that. We'll say we'll put one door over here. At present, when we have what we have put in equest, it is the true north is actually on the top. The true north will be changing later in the detailed. So for now, we'll say that there's one door towards the south and one door towards the east. Glass doors, east 0, 1, and north 0. Width, let's say 3/4, a small glass door. Right, we'll keep it that, and single clear glass. Go to next. So what I did was I'm just trying to define the type of glass over here. So I just said select another. So what happens is it clears out. If you had two different types of glasses, then you can use that. Otherwise, in most cases, you will have a single type of glass. Here, I'm going to use a single glass. And as you can see, its properties are already here, the U value, the SHGC, and the visual transmittance. Okay. Now, if you know this, because if you remember, we know the width of these windows and also the height and the cell height, we can input that and give a percentage, and what will happen is equest will by default put in the windows over here, and we can just later on change anything we want. Now what I'm going to do is convert the length, which is in meters, into feet for entry into here. So the first thing is I know my width is 2.4 meters, so 7.87. Leaving out the frame width, I'll put in 7.5 over here. I haven't made the exact calculation, but just approximated. The window height, we'll say it is 3 meters, so that's 9.84. 9.8. Now if we sum up 9.8 and 3, it will go above 12. And as you can see, the moment I give this, this will be total is higher than the 12 feet total floor height. So maybe I can reduce this to 2. And I know that the maximum windows are on this side, north of the drawing at present in US. So this is the north for it, and this is the east. Let's see how big are these windows. These are 3 meters in width, and the top ones are 2.4 meters in width. So we'll leave this as 40, and if I want to use another input of a different type of window, I'll again select this single clear tint, and here the typical width is higher, which is 9.84. Oops, 9.84. Window width is 9.84. Window height will keep it the same, 9.84, and sill height will keep it at 2. And this is on the east side, put 0 on west and south. Now what this does is, by default, it will create, based on this inputs, it will create windows which we can make adjustments. We'll do this adjustments by clicking on custom window door placement.
Yes.
And click on yes. As you can see, there's nothing over here. And when click on next, you see by default a window is created over here, which is this window. So it isn't created here, it was created. Okay, that's 3. Okay, it should really have been created here, but it got created in this one. Okay, that's fine. And we'll delete any windows that are not present. So these 2 windows are not required. We'll delete this. We'll delete this because in the original geometry, as you can see, there are no windows on this side for the lamp. And as you can see here, we have the windows wherever we wanted. This is an extra window, so we'll delete this. And nothing on, okay, on eastern side. So this should have been, and this is also not there, so we'll delete this. Okay, so the window ideally should have been created here. If it is not created, that's fine too. I think the reason why it was not created is that we never left some space for the frame width. So if I leave some space for the frame width, let me call it as 9.5 and make it 50. I hope this will be created down. Yeah, there you go. And I can just straight away delete this. All right. So it's easier to create more windows and then later on delete them rather than creating windows here, because every time you have to kind of look up the width, height, type it in manually, and that's a lot of hassle. For example, this door ideally should have been over here. So this is 3 by 7. We'll delete this and we'll click over here and create a new window. Width is 3, height is 7. And as you can see, you have to, every time enter this, and the X coordinate will be, let's say, 5 feet. Click on OK. So you can, on this wall, it does not matter. In fact, in this space itself, as long as the direction of the wall is correct, you can create the window or door anywhere. That the exact location. It's not important that it should be in the exact location. That's not at all required. Okay. And we wanted to create one more window or door over here. So say 4 feet, 3, 7, and the frame width will keep it as 1 inch. I'll keep that as 1. And that's really it. That's how you create windows in detailed mode. No, sorry, in wizard mode. You can quickly cross check. Okay. Now, if you feel you are satisfied, that's fine. What we are going to do is actually look at the 3D view immediately after we create the class. So what I'll do is I'll click on return to navigator and click on finish. Now, if you look at the 3D geometry over here, you can see your entire model. Now, there's nothing on the top because we have said that there is, this is just the ground floor. There's no roof for this. So that is why no roof has been created. Now, if you want to rotate this, you have to press Control, and by keeping your left mouse button pressed, you have to move sideways, okay, to rotate. If you want to zoom, keep your Control in the keyboard pressed and your right mouse button pressed, move in up and down fashion, and then it will zoom in and zoom out. Right. Okay, so as you can see, this here is an additional door that really should not have been there. Okay, everywhere else, yes, looks perfect. It has been created where it should have been created. And now what we'll do is we'll click on building creation wizard. If you get a view something like this, where you are in component tree, click on actions and click on building creation wizard. Yeah, good moment to save. Click on yes and click on OK. And then again click on edit selected shell. Right. Again go back to custom window door placement, and this was where we want to delete the door. All right. So that's how you create windows. We'll go to next screen now, and For shades, so what we'll do is, as of now, we'll keep it as none. We'll see in detailed mode how we can create shades. We'll click on next. And here, let's say it's school in session. You just have to create the schedule. This is by default, it takes a schedule. And here we take the schedule from ECBC. Let me in fact pull up a typical schedule for ECBC. I think we can do a Google search here. Give me 1 minute. Right. So type in ECBC 2017. Yeah, you'll find the file over here. Right. And within this, in appendix, you will find all the schedules. Yeah, over here, you see 9.6 schedules. You can go and click there. So you have all the schedules over here. So for example, for a business building, you have the occupancy. If it's a daytime business building, this is the occupancy schedule. What this fraction means that at any given moment, let's say you have 100 people, the total occupancy or total number of people that the building can accommodate is 100. Between 7 and 8, there'll be only 10% of those number of people who will be present in the building, right? So similarly, between 8 and 9, there will be 20% of the people. That means, in my example, if we assume there are 100 people in the building, only 20% or 20 people will be present between 8 and 9. And from 9 onwards, it will be 95%. So 95 people will be present. And similarly, for the lighting schedule, if it says 0.1, that means only 10% of the number of lights will be switched on in this hour. And when it comes to 7 to 8, it will be 30%. Okay. Similarly, for the equipment, the elevator, and we'll see how we create these detailed schedules later. But you have everything over here. So assembly buildings, not sure if there is one for school. Yeah, educational buildings over here. You can see for schools. So you have the student zone and you have the back office zone. So you have two types: occupancy and lighting equipment, and also for elevators and air conditioning, external lighting, basement ventilation, basement lighting. Okay. So we'll be using these schedules for now. we'll just say that, okay, let it stay as is. In the detailed mode, we can always edit it. But as you can see, it starts at 7 and ends by 2. So let's kind of use that. Starts at 7 and ends at 2 p.m. Right, Saturday, Sunday closed. Go to next. Here, just remove all the types of occupancies that you have by either pressing the minus button or selecting select other. The reason is really we just want the occupancy type to be single for the entire 100% of the area, and the square footage per person, that depends on what type of, what the architect has in mind or what the client requirements are. For example, in this classroom, how many people can be accommodated? Of course, National Building Code also has its own suggestions and recommendations. Yep. So, good question by Sandy, which says that a typical school works for 10 months. How to set schedule for that? As I said earlier, that when you see this schedule for educational buildings, one of the basic rules of ECBC simulation is that you keep the schedule.
Hello, sir. Can I interrupt for a minute?
Yeah,
Participants, please put your questions for everyone, as we are not able to see what questions are you asking. Okay. I think they are sending a personal questions to you.
yeah. Mr. Santi, if you can put that same question, or in fact, I'll copy paste that question and put it here.
Thank you, sir.
This was the question. Yeah. How to set the schedule for a typical school that works for 10 months. As I said earlier, when we come to ECBC, it says that you follow an annual schedule, don't take breaks into consideration. Plain and simple. That's what the rule says. So even if in reality you may have 2 months off, but when you're simulating for ECBC compliance, you will not take those off days into consideration. Okay. And of course, we'll come into how you can set the schedules if you want. And I think when we look at schedules in a detailed mode, Mr. Santi, you can probably, Mr. Matthew or Miss Matthew, sorry, please forgive me. You can ask me the same question once again. All right. And if I forget, then I'll show it at that point of time. But we will be seeing the schedules in detailed mode also. Okay, because we have not yet set these percentages yet. Right now, we just when we set the schedule, we just set the timings. Right, it starts at 7, it closes at 2, but we have not yet set the percentages, each individual percentage. Yes, absolutely. We can select 2 seasons, but again, as I said, it's easier if you do it in detailed mode, right? Okay. Let's go to next screen. Oh yeah, before that. So this occupancy, square feet per person, it is recommended by National Building Code. And the fresh air requirements are usually given by, go to next page. Oops. even in ASHRAE 962.1. So ASHRAE stands for American Society for Heating, Refrigeration and Air Conditioning Engineers. So we use ASHRAE 62.1. Those are air conditioning designers who provide the required ventilation. Usually it's about 5 CFM per person most of the cases, but if you have, let's say, a gymnasium or something like that, the CFM per person increases. Now, specific to the question of Ramesh PR, what about corridor area and lab area? We'll keep that similar as of now. We'll assume that it has got the maximum occupancy. We can later on in the detailed mode, we can change that with the individual spaces that we build. We can change the occupancy. So this is just a bridge, what we are doing here is just making a bridge for the detail. Go to next. And here we were saying that the corridor area is unconditioned, right? So what we'll do is we'll create a zone group here. We'll call this unconditioned. Click OK. And we'll uncheck the conditioned check mark from here. And now we just want to assign the corridor. As you can see, this zone group and other zone group. Okay. So everything right now is in the EL1 ground floor group, which is conditioned, and there's nothing in conditioned group, unconditioned group, sorry. So what we'll do is we'll click on this ground floor, left click on the zone and assign zone to active floor. Okay, and click on done. And as you can see, this is unconditioned. This has become unconditioned. Right. We'll click on next screen. We'll leave the lighting as is for now. And the equipment, let's give a very minor equipment, 0.5, because there'll be projectors and all such things. Oops, this was office equipment. Okay. Oh yeah, before that, in fact, one screen that I forgot is, oops, yeah, here, this screen. I think there was a double click and I missed this screen, which is wizard screen number 15. Just give me 1 second. There's a bit of noise. Okay, I think this will be better. Yeah. So you have to define all the end users that you want to, actually define later on in the screen. Whichever you check over here, those screens will come up when you go for next screen. So all we really want is, not even office equipment, not even cook equipment, nothing. We are mostly interested in lighting and miscellaneous equipment. And extra lighting will give and leave out domestic hot water. So I'll take up the question of Ruby in a moment. So we have defined the end users. So we are mostly interested in these. And I'll go to next screen. We'll leave 1.45. This is 0.5. Leave it at default. And this really, external lighting, it's usually 10 hours a day. So what I'll select is connected intensity and seasonal profiles. So there will be just one season defined, and I'll give it, let's say, 1 watt per square feet. As of now, we can define this later on, right? Okay, so the zone group question over here, the zone group question. So if you have a split AC, do you want to create a separate group for that? No, not really. For now, just create a group, or in fact, you can actually create a group if you have, mm, different types of systems serving different spaces. But for starters, it's very easy to just keep two things. One is conditioned zone and the other is unconditioned zone. Right? Just so that you don't get confused. So click on next screen, click on next screen, click on next screen, and return to navigator, and just click on finish. And of course, once in a while, click on save button. So what we have done right now is for the ground floor, we have defined the heat loads, okay, the building geometry, except, oops, I'll not write, except the orientation, and then you have construction materials, roof, wall, and windows. Okay, I haven't defined lights, occupancy, equipment, schedules. We have not yet defined in a detailed matter, but we have just said, okay, it starts and ends and infiltration. So this is more or less done in your wizard mode. Okay, so one question from Sandy is, if we have an open space between GFL and FFL, how do we zone it? So I assume you are asking regarding something like atrium. So in those cases, you don't really have to do anything. Just prepare a zone just like it is. So for example, if we had this, let's assume that the corridor that we have, okay, this corridor, yeah, I can't make it double. Okay, what we'll do is we'll make this classroom double heighted, right? We'll make, or in fact, one of the labs as double heighted, right? So which will represent an atrium to, answer the question. So really, all we have to do is we have to take both the zones and serve it by the same air conditioner. That's really it. That's all we have to do. Don't have to do anything else. The other way around is you create a zone separately and increase the heights in detailed mode, which is of course an advanced level of request. Right now, for basic purposes, just take the zone on the bottom and zone on the top, and you serve it by the same. Let's say it is served by one split AC. So both of them, both the bottom zone and top zone will be served by the same split AC. So that's it. In modeling, you don't have to do anything different. Yep, there's no need to show it in the 3D model. That's right. Okay. Moving forward. Now we have to create the first probe. Building creation wizard. Click on yes. What I'll do is I'll create new shell. I can copy the data from the previous one, or if the footprint is different, then I'll take a fresh one, okay, and follow the same process that we did for the first floor, sorry, for the ground floor. I'll go to screen number 1, and what I'll say is I'll position this entire shell immediately above the first one that I created. So this is the ground floor one that I created, and this is the first floor. Also, just check, specify exact site coordinates and make sure that these are 0, 0, and this is 12. And if I click on next, and if I just click on finish right now, what will happen is that you have created another floor above, and as you can see, the roof is not yet created. So you have to create that. Click on yes. Click on edit, and as you can see here, we'll select 6-inch concrete, and without any insulation. Okay, let's ignore the plasters and other things for the time being. You know, you have plasters also. You can, in fact, if you want, you can create and do all those, but that's fine. Let's leave as is for the moment. And here, as you can see, exposure, the ground floor, it automatically takes over conditioned space. Leave it at that, and no insulation. Sorry, somebody has a question. Okay. Yeah. Right, and everything else we are leaving it the same. Everything else is just copied from the top. Return to navigator and finish. Okay. Look at 3D geometry, and as you can see, the roof is created now. Yeah. Let's save this. And now let's look at the air conditioning in the wizard. Okay. Let's look at here, and the different types of system. I'm going to probably give a very brief introduction, maybe in the next session. But for now, we'll use DX coils, okay, and no heating. Actually, ECB says that even if you don't have any heating, you should choose electric resistance. So we'll say that it is electric resistance. And as you can see, most of you are aware with the split system, single zone DX. We'll use that for the time being. And later on, when we look at the different types of systems, I'll probably explain what each type of system you can take. Right. Go next screen. Oops, before that, okay. Yeah. Oh, before that, I forgot one thing to do in the top row, that is remove the windows on the outside. Exterior windows here. Oops, start here. Let's delete these windows. All right, return to navigator, and we'll continue with the air conditioning system. Yeah. So we'll keep this very simple. Every zone has its own system, split system, and here we specify the set points. So whenever it is occupied, we'll say that Celsius to degree Fahrenheit, we'll say it, we'll set it at maybe 24. So set point 75.2, and heating set point, if you know, if practically there is no heating that is going on, just decrease this temperature. Okay, and just give me 1 second. Okay, hello, can you hear me? Can everyone hear me? All right.
Yes, sir.
Okay, great. Right. So when we are designing air conditioning systems, what we do is we always say, if you see any document, you'll always see 24 plus or minus 2 degrees Celsius. Okay. If you see any HVAC report or design report, we call that as DBR, design basis report. You'll always find that it is 24 plus or minus 2 or 25 plus or minus 2. They'll give a certain percentage or acceptable range. Okay, so here what we do is we set, for example, for cooling, we give the set point, the same set point as mentioned. Okay, and 20, let's say it is 24. Sorry, I'm sorry, the set point is design temperature is over here, so 75.2 will be over here, and when we say plus or minus 2, so that's the comfort range. So this is the design temperature we are designing for 24 degrees Celsius, but really you are comfortable till 26 degree Celsius also, right? So when I say 26, it is 78.8. So 78.8. Okay. I hope this point is clear. So in any air conditioning DVR, you will see something like this: 24 plus or minus 2 degrees Celsius. Okay, so 24 is your design temperature, and 26 is acceptable / comfort. Okay, so that is exactly what we are specifying over here. We are specifying the cooling design temperature, and you're really comfortable till 26 degree, which is 78.8 Fahrenheit. Okay, so what happens is that the air conditioner will switch on the moment the space temperature goes above 26. Okay, this is the meaning of this temperature. Okay, similarly, when it comes to heating, the moment the temperature, the inside space temperature goes below 20 degree, the heating element will switch on. And really, that will be almost impossible where the temperature will go below 20. So heating equipment will technically never switch on. So that is how you can, tweak your model, right? And when it comes to unoccupied tanks, wherein there is zero occupancy, you give such a high temperature, it's like 120. So what will happen is, till the space temperature reaches 120, the air conditioner will never switch on during unoccupied times. And this is almost impossible, that the space temperature will go to 120 degree Fahrenheit. 120 degree Fahrenheit, if you see, is technically 48 degrees Celsius. It's too high, if especially when your air conditioners are or when you have clearly defined in the schedule that on those days AC will not operate, right? Or even there's no occupancy. You can also take it up to 140 if you want to be sure, because sometimes in Rajasthan and all you can hit this temperature. So you can take it to 60 degrees Celsius. It's almost impossible that your space temperature will reach 60 degrees Celsius. And similarly for heating, you do that. Okay, so this basically indicates only if the temperature of the space goes above 78.8 will the air conditioner switch on. The moment the temperature drops below 78.8, the air conditioner will switch off. Okay, this is like an on and off, and this is more like the design. Okay, so you are designing for 24 degrees, for the space temperature should be at 24 degrees Celsius, but up to 26 you are comfortable. Okay, and between the design temperature and supply temperature there should be 20 degree Fahrenheit temperature difference. So I set this at 55.2, and heating I'm not really worried about, because I have artificially set in such a way that the heating will never be switched on. Okay, some good questions. What if we have equipments like server in unoccupied rooms? Yeah, for those cases, specifically server rooms, you will create another schedule wherein you'll have your air conditioning equipment will run 24 hours. For that, we'll create different schedule. Now, since this is a school building, we'll use this. And in fact, within the next maybe another 5-10 minutes, we'll be taking up schedules in detail. And at that point of time, please both of you can ask the same questions and you will actually get your answer. Maybe another 10-15 minutes we'll be discussing. So special area like server room where machines are running 24/7 and its temperature can exceed 25 degrees. Yeah. So right now we are not talking about server rooms. This is a simple space. So if your specific question is if it exceeds 25 degrees, then automatically the air conditioning equipment will switch on and the air conditioning equipment will try to bring that temperature, space temperature below 25 degrees. So in this case, it is 26 degrees. Okay, so that is what we call as thermostat. Okay, so thermostat is basically, it's an on-off signal. Thermostat gives you an on-off signal. So the moment temperature goes above 78.48, it will give an on signal. The moment it drops below 78.8, it will be an off signal. So that's the work of a thermostat. Right? Any specific queries on this screen, like with respect to air conditioning equipment? If you have any specific queries, probably we can address that. Otherwise, these two questions we can take up when we look at detailed. So may I request Mr. Varghese to kindly mute probably. Okay, thank you. Now cooling equipment, we'll leave it at auto size for now, and we'll discuss what these items are in the next session. All right. We'll leave it at default because for that I just need to give all of you a brief about air conditioning. For now, we'll make it as the auto size ratio as 1. We click on next screen, and here what it says is air conditioning system. It starts at 1 hour before and closes 1 hour after. If you look at the schedule given to us, you see the HVAC fan schedule. Here you will see it asks us you started at 7 itself, okay, which is an on-off schedule. The occupancy starts at 7 and you start it at 7 itself. In reality, if you look at big buildings where they have central air conditioning system, the load, because the air conditioning equipment has stayed off the entire night, there's a lot of accumulated load within the building, and the moment you start, what will happen is that in the first hour, the comfort conditions, that is 78.8 degrees, we will not be able to reach. So here we'll take it up as 7 AM and I'll just set this as 0 over here. Okay, so automatically take it as 7 and the end time is at, oh, so we have two different times, one for back office, one for the school itself. So we'll take the school area, the student area itself for now. So it ends at 2. So this will also be given. right? Click on next screen, and here will this usually no economizer. We'll discuss a little bit more about economizers and air conditioning in the next half. We'll click on return to navigator, and we'll click on finish. Okay. And click on save. So now we'll switch to detailed mode and in fact look at schedules. The first and foremost thing that we are going to look at is schedules after switching to detailed mode, right? So let's go ahead and switch to detailed mode. So under mode, you can go to detailed data edit mode. And under the component tree itself, you can actually resize this window if you want. And if you come down, you see all of your constructions. Yes, brick walls that you had created earlier. You have the same layers as you can see, which you had created, and the materials. So material goes into layers, which goes into construction. So we'll discuss construction a bit later, but first let's look at schedules. So if you scroll down, you'll see you have annual schedules, you have weekly schedules, and you have daily schedules. Okay. So the way this works is the daily schedule goes into weekly schedule, which goes into annual schedule, right? So let's look at first is the, and WD stands for weekday, WEH stands for weekend holiday, HDD stands for heating design day. There should have been another one, CDD, which is cooling design day, but for us, everything is the same. In fact, we'll take a very quick look at what it is. So as you can see, the same fractions are provided over here, and all you have to do now is just use this fractions. Okay, so it says that for the occupancy schedule at 7 it is 0.7, and till 10 it is 0.9. So at 6 there's nothing. Oops. Restore default. So when I click on right click and click on restore default, it copies the schedule just before that. And from 7 to 8, you're saying there'll be 70% occupancy. From 8 onwards, it will be 90% occupancy till 12, I believe. No, till 11. Okay. And then there's a drop in occupancy, and then full occupancy till 90% occupancy till 2. So here, this is, I right click on restore default, 0.2. This will be 0.9, and after that it's 0. Right. So I can probably rename this as oops. We'll rename this as student zone. Okay. Call this as student zone occupancy weekday. Click on tab, and you can choose any other schedule from here if you want. So for example, weekend holiday, which should be 0. So we'll make everything 0 over here. Yeah. And here HDD is something which is for the design day. Similarly, a CDD is there. So for us, CDUDD will be equal to cooling design day will be equal to the weekday itself. So we don't have to worry much about the HDD. And now you can switch to week schedules. And as you can see over here, by default, the week is already set up. And I can rename this as student zone. I'll go to annual schedules and rename this also student zone occupancy schedules. So whatever is the annual schedule, that ultimately goes into the space. Okay. Now, as you can see, there was a question earlier regarding number of seasons. If you wanted to incorporate number of seasons in here, all you had to do is create another week schedule. Okay. Let's take, for example, create a schedule which is a holiday schedule. Okay. School holiday. We'll call this a school holiday week. For week, we give a notation WK in the end. I'll copy the student zone occupancy week itself, but what I'll do is I'll change everything to weekend holiday. Right? Click on done. And then in the annual schedule, what I'll do is I'll insert weeks. So let's say we have summer holidays. Okay, I'll insert 2. Let's say from 1st of May, we have holidays. So ending month will be 4 and ending day will be 30. So till 30th April, the college or sorry, the school is in operation. From 1st May till let's say 30th of June. So this will be ending month is sorry, June is 6, ending day is 30. We'll say that it's a holiday. So you understand, till 30th of April, there is normal occupancy. Then from 30th of April onwards till 30th of June, we have holidays. And from then on till the end of the year, we have normal occupancy. So that's how you create. If you want to create different, seasons or internal schedules, annual schedules, you can do that. Okay, but what ECBC recommends, you leave it on for the entire year with the same schedule. Okay, so again, if you want to create 24-hour schedule, all you have to do is let's say the equipment. Here equipment, you can see this is miscellaneous, building miscellaneous weekday. This equipment, you want to create an equipment schedule which is 24 hours in operation. We'll create. You can just copy, click on OK, and let's say a server room which is operational throughout the day. So this is, you see, the type is fraction, and we'll call this as server weekday. Done. Create a new. So all I do is right click, then server week, because it is fraction. All I do is change this. I click server weekday. So entire thing will be server weekday. So which goes into server week, and then the annual schedule, server, just leave it, and change the week schedule. Okay, so server schedule you have created. So that's that. And okay, there's one question. For all unconditioned spaces, they'll be having fans. So fan is nothing but what you're talking about is ceiling fan. You can it's a miscellaneous equipment, you know. You can just include it as a miscellaneous equipment. In, let's say, in corridor there was a fan, you can just add it as a miscellaneous equipment, because we are not really seeing the thermal comfort in that space. If you are talking of thermal comfort in unconditioned spaces, equest cannot do it. So you have to equest can only test thermal comfort in conditioned space. So that's one of the major things that you have to know, right? Okay, so I think I can take up a few questions now. Any more questions? And we can probably break, and then in the next half we can look into air conditioning systems in detail. Any questions? 5 minutes. Take questions.
Participants, you can unmute yourself and ask anything you want.
Hello, sir.
Hi. Yeah.
Hi, my name is Fasna. So I just wanted to ask that the schedules we have been creating, there are many light schedules, occupancy and everything. So are we using these schedules somewhere? I mean, is it linked to any of these things later on, or are we just keeping on
Yes.
to that?
Yes. It will be used. I have not yet shown that. It will be used. The first thing is creation of the schedules, and then the second is assignment. So you have to create and assign. There are two things. You have to create everything over here in equest. One is creation and there is assigning. So everything that you create has to be assigned later on. I have not yet shown the assignment part, which I'll be showing in the second session.
Okay, thank you.
So good question. The size is important. The location, as long as the direction is same and the space is same, doesn't matter. So for example, if I go to a 3D geometry view, if this window, if it's placed on this wall, it's perfectly fine. There's no problem, because this wall also belongs to this same space, which is this one. See, this window is part of this wall. This wall is part of this space. So I can make this window part of this wall, but still it will be in the same space. It will be in the same space, and pardon me, it will be in the same space, and the heat load will go into the same space. So we are actually interested in the heat load of the space. All right. So it doesn't really matter if the window is on this wall or on the other wall. Okay, as long as the orientation is same, the window size is same, you can go ahead. The exact position does not matter. You can further modify it if you want in the detailed mode. I can show you how probably later on. Any more questions?
Okay, sir, as there is no more questions, we can conclude the section for right now and we can come back after lunch.
Yes, absolutely. Yes. We'll
Okay.
assemble at 2 o'clock.
Participants, I think we have to assemble by 2. Okay, sir?
Yeah, by 2 o'clock we'll assemble back. Yeah.
Okay. Thank you, sir. We'll have a break right now. Thank you.
Right.
This conference will now be recorded.
Yeah, just a minute. Right. Okay, we'll continue from schedules. That's where we had left off, and uh, so I hope everyone is clear regarding the schedules, creating schedules. But I think one important step or one important schedule, couple of important schedules I missed is the fan schedule and the cool weekday and the heat weekday. So these are the air conditioning schedules. So if I remember, we had given thermostat set point of 78.8. So that is what is reflected over here, right? So above 78.8, the air conditioner will switch on. The moment it goes above, the space temperature goes above 78.8. So essentially, the air conditioner is trying to maintain the temperature of 78.8. That's that. And of course, fan is just a 0 and 1. 0 means off, 1 means on. That's that. Okay. So when you create all these schedules, you create the daily schedules that go into weekly schedules that go into annual schedules. You see, here the spaces are created, and on the top you have internal loads. We'll come to constructions in a bit. Hello, am I not audible?
So you are audible. It's clear.
Okay. Maybe you could try increasing the volume at your end. Okay. So if you switch to internal loads, you see each space. Okay. You can go to spreadsheet view, and here you have the spaces. And as I told you earlier, any unconditioned space is reflected as unconditioned here, and of course in the airside HVAC also, it will be reflected as unconditioned. Now, if you go to occupancy, here there were a couple of questions. For example, in the corridor, okay, where the occupancy would be different. So you look at that, go to spreadsheet view, and you can actually change the number of people. So let's say there'll be just about 2 people over here. So you can, change that. So that's all you can do. And whichever, you see over here, whichever annual schedule you have created has to be assigned over here. All right. So that's number one. So here, for example, lighting. Again, this lighting watt per area. So what does this watt per area mean? It means is whatever is the total number of lights, you sum that up, sum up the wattages and divide it by the area, you get watt per square feet for that. And for the baseline, in fact, in KS ECBC, you can refer to the lighting section where you will have building occupancy as well as building wise occupancy as well as space wise occupancy. So the question, where do you get the standard occupancy numbers for typical buildings? I think you should get it in NBC, National Building Code. That should contain all those details. If not, you can just get it from the architect, or you can just whenever the internal layout is finalized, you can just count the number of furniture, number of seats, and you can accordingly put that in here, right? So that's for lighting. Then you have equipment also, which is you have taken 0.5. If you want to change a specific, for example, just for this one, all you have to do is like in the spreadsheet mode, this is the corridor, and you can see which one. One of the first things that we do is basically rename these spaces. Okay, so you can, for example, just rename these spaces. What we had was, this was, I think, so this was classroom 4, right? Room 4. Then you can just, all I did was pressed from here. From here, after renaming, I pressed Shift and Tab, and then down arrow, and then press Tab again. Classroom 3, classroom 2. So you can see whichever zone is the current zone is also highlighted in the background. Classroom 1, and that's laboratory, lab 1 and 2. Lab 1, and you have lab 2, right? In fact, this is for the ground floor. We should have actually put in the ground floor also. So I call it, say, L0, level 0 corridor. Okay, and similarly go to this spreadsheet view, 0. So here your typical copy paste is a bit tricky. So double left click, single left click, and then paste. Okay. So that's your space name. Every space name should be unique. That's number one rule. So there are some shortcuts that I'm quickly going to show. If you have to, let's say I want to rename this second floor because everything is just a copy of this. If I know that, I can just press Control C and Control V over here. L0, replace L0 by L1 and press Control C over here, double left click and paste. Here the usual, if you press Control V, is not going to work. You have to get into it and then right click and paste. The shortcuts don't work. That one and so on. Okay, let me enter. And there you go. Oops. Right. So immediately after you rename the spaces, well, one other thing that you must always do is rename the zones in airside HVAC. So if you click on the zone and go to spreadsheet view, we have the zone names. So these zones are created in the same order of the spaces here. Okay, so these are in the same order. Okay, so each zone, as you can see over here, these are the space names, and corresponding to each space name, you have to give a zone name. So I just use a formula. Percent this percent is certain, and it should be unique. Okay, so that's why percent. Okay, more. I think that should it. No. Four and that should be it. Yeah. Okay. Sorry. In this case, I didn't need the extra this. So okay. Sorry. That was for another thing. Yeah. I'll just put in this much. It should be okay. Why isn't it? Yeah, there you go. So what I do is copy this and paste it here. We're going to use this later on, so that's why I'm renaming everything. So always make sure that it is unique. Sometimes you encounter errors just because of mismatch of names. If you have just two of the names similar, for example, if you make L0 lab 1 ZN and the next one also L0 lab ZN, it's going to create a conflict because everything should be unique. And you can always cross-reference here. So whichever you are copy pasting, you just make sure that this is the same corresponding space. Oops. Here I have, okay, this one. And over here. Oops. Yes. So that's that. And of course, the systems I think we will not touch at the moment because we are going to do some reordering later on. So we'll leave the system name as is. If you click on the system, in fact, you see these systems should also be renamed. And the unconditioned zone, for example, the corridor ones, as you can see, they are the system type sum. So any unconditioned zone should be in the system type sum. And after that, let's go back. Once you're done with renaming the spaces, let's go back to building shell. And let's look at all the constructions over here, right? So when we are in constructions, it's really ideal to create layer by layer constructions. So here the idea is that there is materials which goes into layers, which further goes into constructions, and these constructions are then assigned to the space. Okay, so what happens is for each space the heat load is determined, just like we spoke in the morning. Over here you have heat loads external, you have heat load internal, and then the air conditioning equipment. So for each it is determined. Right, so that's that. And one more important thing that I forgot to mention was the orientation. Okay, so as you can see over here, we have to change this north so that it comes to, if I remember correctly, it was 43 degrees from here. So we are going to do that. And this is, I think, minus 43. Yeah. Okay. So here under building shell in building data, you can give the azimuth. It is anti-clockwise if I remember. So I gave minus 43. So it just the negative came here. And east was shifted 43, I think. So that's how you do it. You change the orientation. Okay. After that is the constructions. As you can see over here, you have material, you have layers, and finally the construction, which is then assigned into each space. We had created brick wall and we had also created the roof construction. It'll be great if you can in fact rename this as, rather than brick wall, just rename it as proposed, because later on you are also going to create the baseline brick wall when you go for the KS ECPC compliance. So I rename this as proposed brick wall for now. Eyewall construction, I'm not really interested, but you can just still, this is a gypsum board wall. You can actually create, in fact, over here, just go to library, common 8-inch, and give a cement mortar over here too. So that's fine. So all the internal walls will be this construction. Okay, floor construction, we are not interested. The roof construction, yes, I am interested. So I'll rename this as proposed roof construction, let's say. And as you can see over here, is concrete and then slight amount of air gap, air resistance, and built-up roofing, which you can actually change it to, if you want cement mortar. And this really, or maybe here you can change it to cement mortar, and here maybe tiles. Yeah. So it should be always from the outside to the inside. As you can see over here, it's written material layers ordered from outside to inside. And you can change thickness over here if you want. Okay, so that's proposed roof construction. And these constructions are then assigned to each of the wall. And this is the class. So here, although it has taken from class library, you can also change it to simplified if you know the three properties of glass, that is shading coefficient, U value, and VLT. Generally, they are provided in the data sheets of all the glass glazing manufacturers like Saint-Gobain. So I'm going to take a single glazed glass. I'm assuming single glazed, and this will be conductance will be 5. So transparency, that's right. So yeah, and click on done. I'll do the same for the glass door too. Make it simplified. Coefficient 0.8. Transparency. Okay. All right. And let's say one of the glasses, or for example, on over here you had double glass in the proposed case. So you can actually select that glass and just change the glass type from here. So here it says the type of glass. Right? You can define a new glass and then assign it here. So that's how it is: create and then assign. Okay. Right. So now you have completed your building shell and your internal loads. Now we are left with air side and water side HVAC. Let's look at HVAC and let's try to understand the types of them. Okay. So one of the major things that you have to understand that there are two types of air conditioning. One is vapor compression, the other is vapor absorption. Okay. Now The technique of each is different, and the way that this works is also different. Before I go into further detail, I think there's a question. What is the advantage of using layer construction in place of U value for walls or roof? Well, now I hope you must have heard about specific heat capacity and time lag. So what happens is, what specific heat capacity means is, every material can only withhold some amount of heat, and when that heat trapped in that exceeds the amount of heat that it can store, everything else starts getting transmitted from a lower temperature on one side, sorry, from a higher temperature from one side to lower temperature on the other side. Okay, so technically there is no advantage, but what ECBC, or in fact what not sure if we should even say ECBC, but the best practice is to create layer by layer constructions. That way you can actually get the time lag into effect. The reasons I'm saying this is, imagine, think yourself on a typical very sunny day. When do you feel the most heat inside the room? Let's say you don't open the windows and doors. Do you feel it in the afternoon when the sun is west facing and it is direct, it's hot? Or do you feel it at the night, in the night? Now that happens. Any guesses? In fact, you can type in the chat box. When do you feel the most heat? Is it during the afternoon or probably sometimes in the evening? Okay, so the few saying it's in the evening, 4 p.m., afternoon. I'm talking about a simple brick wall construction. Let's assume concrete, simple concrete brick wall. So you will feel it towards the evening, late night, because of the time lag, because it is heating up. The sun is heating up, and there's a certain capacity after which it will start transmitting heat to the inside, and that happens towards late in the evening. Okay, so when the entire heat capacity is completed, then it will start transmitting inside. So that is why it is highly recommended that you model it. When you're modeling, you model it layer by layer and not provide a U value directly. So what, in fact, for people who might be new to this, just a recap on what is being said about here, where, as you can see, the specification method, we have layers input. There's another option called as U value input, wherein you can directly input the U value. Okay, I've not gone into depth into U value or R value, but if somebody needs it, probably they can just ping it here, or ideally attend any other conference, because there are a lot many conferences being organized. You'll get an understanding of what U value is and what R value is. But if somebody needs a quick recap, I can give it. So here you can specify your U value directly, the U value, or you give the layers input. So that was what we were speaking about. And coming back, our types of air conditioning. We have vapor compression and we have vapor absorption. Now, vapor compression is the most widely used technology. It's used in almost 99.95% of the buildings. And vapor absorption is really only at a very few places they are being used. Now, in vapor compression, we'll take up vapor compression first. You can have, let me in fact tell about the components. Okay, so the first thing that we mostly talk about is the compressor. The second is the evaporator. The third is the condenser. Okay, condenser, we have subtypes. One is called air cooled, the other is called water cooled. So these are the main components, and condenser can only be one, either air cooled or water cooled. It can't be both. Okay, and when it is water cooled, we have something called as cooling tower. Okay, so these are the components that you have to model, and of course you have what we call is for along with evaporator we have supply and return fans. Okay, so basically everything, all of these are nothing but when we say evaporator, this is nothing but a heat exchanger. When we say condenser, these are all heat exchangers. So you just have to probably in one of the detailed conferences you can have a look later on. So you have compressor, evaporator, condenser. Now compressor is the one which takes most of the power. So you can say that approximately 90% of the power is drawn by compressor, while evaporator, which is basically just a fan, a heat exchanger, is very low, and the condenser is very low. Most of the power goes to the compressor. So I'm not going to talk in detail about the method of working for different things or the refrigeration cycle itself, but you have to understand that when we model the compressor, okay, by specifying its efficiency. For compressor, we specify the COP, coefficient of, which is coefficient of performance or efficiency. What is the thermal output? The cooling output divided by the input. Okay, and then supply and return fans, we just use the demand load, that is kilowatt, in terms of kilowatt. And condensers, again, cooling tower, which is great design topic, but you basically model the power again of the cooling tower. In fact, here also cooling tower, it has got a fan, cooling tower fan. And of course, there will be pumps when different when we use. So in package system, let's deal a little bit more in packaged or strict systems. So the only thing, the connection between 1, 2, and 3 is that the refrigeration, the refrigerant. Okay, the refrigerant can be these days we have R32 as one of the refrigerants, which has low ozone depletion potential and global warming potential. Then you also get R401A, and there are several other refrigerants. So basically, these are all HFCs, hydrofluorocarbons. They have just been coined names over here. You also have R134A. These are the famous refrigerant, and you might also know that R22 is completely banned and has already been phased out because it is a CFC, chlorofluorocarbon. So in packaged or split systems, the refrigerant is the connection between 1, 2, and 3. So refrigerant is flowing from compressor to evaporator to condenser. Okay, and it is mostly air. Most of the condensers in package systems are air cooled. There may be situations where the condensers might be water cooled, but those are very rare to find. In only a few places will you find that for a packaged or split system, the condenser is water cooled. Okay, and then you have centralized plants. In centralized plants, what happens is you encounter something called as chillers. So chillers means that the moment you introduce chillers, you understand that the link between you'll start having water circuits. The moment we take chillers into consideration, you can assume that there will be water. In packaged or split systems, the only thing that you have is refrigerant. There's no water involved. Okay. And I'll take one question which has been asked by Anish is there any component called throttle in VCR system? Yes, there is a component called throttle valve, which I deliberately did not tell here because that is really not used in simulations. And you can actually look it up if you want to understand what that throttle valve does. It's an important piece in the entire system. You can study the refrigeration cycle and you'll understand the important cycle, but when it comes to simulation, I really don't need the throttle valve. So in centralized plants, you have chillers. So chillers effectively encompasses compressor, evaporator, and condenser. Okay, and then you have a water circuit which is connecting the supply and return fans. In fact, let me see if I can pull up an image. 1 minute. To understand this concept better. Okay, so this is what is the throttle valve. It's an important piece of equipment. I'm not going into the details of that, but yeah, when it comes to centralized systems, as you can see, you have the refrigerant, and this entire piece of in the middle is the chiller, and then you have water circuits on the right and on the left. So the water, as you can see, it goes out at about 7 degrees Celsius, goes near the space where it transfers heat to the air, which is coming from the space, which is through return fans, and it is cooled and sent back again to the conditioned space. So if you have return air at about 23 degrees Celsius, it is cooled to about 15 degrees Celsius and then sent. There are losses in the duct, and because it's a huge space, the amount of air that is being supplied into the space is, I would say, about maybe 10% of the entire space volume. So don't be surprised as how do we maintain that 23 degrees Celsius in the space with when you're supplying 15 degrees Celsius air. Just have to assume that so you have to assume that there is heat that is being generated every second. When we talked about heat load system, heat load calculations, every second heat is being generated, and if you have 90% of the space volume which is heated, and then you just put about 10% of cooled air, it really won't change the temperature a lot. So technically 15 degrees Celsius would ultimately result in if the space temperature has increased by 23.2 degrees Celsius, when you put in 15 degrees Celsius air, it will come back to 23 degrees Celsius. So that's the effect that you have to kind of imagine. So 7 degrees Celsius water, it gives heat to the air handling unit. We call this as air handling unit, and then returns back at about 12 degrees Celsius, and then again it gets cooled by the refrigerant. So entire heat is being transferred from left to from the right of the page to the left. So heat is being transferred. So now another good question: in air-cooled chiller, will the left-hand side loop still be there? No, it will not be there. As I said, when we say it is water-cooled, we will have cooling tower. Otherwise, it will be an air-cooled. So if I remove this, the water circuit on the left side, it will be an air-cooled chiller. Okay. And then you have these pumps, which are chilled water distribution pumps, primary or secondary, and condenser water pumps. Okay. So what happens is, in package systems, your single system is maybe catering to 1 or maybe 2 or maybe 3 zones, but when it's an air handler, the entire floor is catered to. So air handlers are basically bigger in size, and they cater to a huge amount of rooms. So that's one of the basic things that we have to understand. And yes, when we model it in here, we'll see how you can model both VRF systems, split systems, and any kind of system. Okay. So with that, let's take a very quick look at air side system with this background. Any questions till now? If there's any questions on this diagram or anything, please feel free to ask. I can probably take questions for a minute or two.
Sir, I have one question.
Yeah.
So, if it is a centralized system, like in the cooling chiller tower and all, then here, as we have modeled it as a single packaged system for all rooms separately, right, sir? Till now, what we have done.
Right. Yes. over here in
So if
our
it is
equest,
a
right?
building, how will be the modeling done?
In a big building, right? In a building where there is centralized system, how will the modeling be done? Correct.
Yes.
Right. Yes. So we'll be taking that up. I'll be showing how you can model different types of systems. After package system, I'll take up the centralized system immediately after this, after the question answer session. So immediately after that, we'll take it up. So we have another question for VRV system. What is the efficiency factor? Is it COP? Yes, for all cooling systems, we take COP, which is coefficient of performance, as the efficiency factor. So coefficient of performance means it is the efficiency. Of course, you will also encounter something called as IPLV, which is integrated part load value. We'll talk about that separately. That I think maybe tomorrow, if somebody wants to understand, we can take that up. But specific to our simulation, it is COP, coefficient of performance. And when we say when we take coefficient of performance, there are two things. In the case ECBCs or any standard that you look, the COP is at standard conditions or rated conditions. Okay, so there are certain test standards which will tell you, for example, split AC, for example, it will be tested at 35-degree outside air temperature. Okay, and whatever the COP at that 35-degree outdoor air temperature and indoor, of course, I think 23 or 24, those are defined by the test standards. Okay, so the COP are mentioned in any standards or ECBC is as per those testing standard. So we call it testing standard. So AHRI testing standard and all those things. But design conditions are completely different. At design conditions, your COP will be lower, because what do we mean by design conditions? Is that, for example, let's say in a city like Thiruvananthapuram, my design condition will be outside air, say around 40 degrees Celsius, and relative humidity about 80% relative humidity. So that will be my design condition. But your rated is 35-degree outside air. So design condition COP will definitely be lower than your rated COP. And when you enter the COPs into equest, we always take the rated COP, not the design COP. Okay, that's one important thing to remember. Okay, one more question is, can we model BAM chiller in simulation? Yes, absolutely, we can do that. We'll take that up also. So just for everyone's brief overview, for vapor compression system, the compressor over here, electricity is the main input. Whereas when we talk about vapor absorption, it is heat, waste heat from any heat source. It can be hot water, it can be gas based. So the major input for vapor absorption is heat. Okay, so yes, we will model it. We'll model the BAM chiller also. I'm going to show that here immediately after the package system. Yeah, any other questions? Yeah, please feel free to ask. Yeah, approximately cooling tower is sized 1.25 times that of chiller. That's just a rule of thumb, but these days they do it at even lesser value. Maybe chiller size will be about 1.1 times that. Sorry, the cooling tower size will be approximately 1.1 times that of chiller. So the tonnage specifically. Okay, where can we get the eQuest application? You can Google search. It is free, and I'm sure the EEB cell can help you with the download of eQuest and other things. Okay. Is the relation same in case of VAM chiller? No. In vapor absorption, you require almost 3 times the cooling tower size, I think, at least I think, because you need to cool down the water significantly in vapor absorption machine. So the cooling tower requirement will be, I think, 3 times that of vapor compression. Okay, yeah.
One doubt,
So,
sir. It is three times the vapor compression, or it is 3 times the chiller?
Sorry.
Sir, you are told that warm chiller cooling tower tonnage is 3 times compared to the chiller rating or ECR compression system.
You see, the chiller size will remain same whether you take VAM chiller or VCR, vapor compression or vapor absorption. Either chiller, the tonnage would require this would remain the same in both the cases.
Okay.
But the cooling will change.
It is 3 times, right?
Yeah, approximately. That's what I think so, if I remember it correctly. But yes, it will be higher. It will be approximately 3 times.
Okay, thank you, sir.
Okay. With that said, let's deep dive into the HVAC side. Okay. Now, here you can actually see over here the zone locations. Okay, so for classroom, if you click on the system, it just shows where each of these is located. Now let's say, so this is pretty straightforward. If it's a split system, if it's a split system, each zone gets its own, so this is a thermal zone and this is the system. So basically, this is the outdoor unit. Okay, and of course the indoor unit is also kind of integrated into this. It's pretty straightforward over here. You can see package single zone. So what happens, the difference between package single zone and a split system is that it's just the piping, it's still the refrigerant, but the refrigerant pipe length is higher, and the indoor fan is disconnected from from the entire unit, the outdoor unit, while in package system the fans are along with the evaporator and along with that, so everything is like in a neat one single system. So that's why it's called a package system. Okay, so question is, if TR requirement is large, which system would be better? Now you have to understand that from the perspective of applications. Okay, as I said, vapor absorption machine requires that you have large amount of heat. So if you have a large amount of waste heat, for example, go to any power plant, they generate a lot of waste heat. And if you do that waste heat recovery, and they also have this administrative buildings and complexes and everything, so you can actually see that it is application specific. So if you have huge amount of waste heat, there you can use vapor absorption chiller, VAM, okay, vapor absorption machine. But if you don't have waste heat, you would probably go for vapor compression. Okay.
Sir, one doubt, sir. Normally for hotels, if it is having some 50 or 60 rooms normally, so going individually with split AC or a centralized chiller will be, which will be consuming less in specific power.
Okay, so big hotels, they generally go for a centralized plant. One of the reasons is that each unit or each room have their own unit which can be controlled, right? So the user inside can on or switch off the AC. And in fact, in big hotels, you need the air conditioning on at all times. And since the rooms are large, you really can't have split ACs over there. But if you have small rooms, you can, all you want to do, you wouldn't want, in a hotel, if you're going to a hotel, you don't want to switch on multiple ACs, right? You just want to have one switch, and then, if you switch on and your entire room starts getting cooled, you don't want to go and switch on multiple ACs. To give you a bit in perspective, let's say a thumb rule is that every ton, okay, so 1 ton of machine, we say that it can condition about 200 square feet of room area in a good building, which is slightly insulated and there's not too much of sun that is falling. But if you go into your own bedrooms, okay, you probably have 1 ton or maybe 1.5 ton machine, okay. But if it is a larger room, let's say 600 square feet, and if you say have multiple rooms in the hotel itself, high-end hotels, they have multiple rooms also. So you don't want to go and switch on different ACs. And of course, the power of the fan in a split AC is always less than the power of the fan of a huge centralized system. So a centralized system, you can have a bigger fans. So to answer specifically your question, which one is better, you can't really say which one is better. It is always application specific. For a small hotel, probably it's good to have split ACs, but if it is a very big hotel with I would say 100 rooms at least, then it makes sense to go for centralized AC. Okay, but if it is only maybe 30 rooms or maybe less, then it doesn't even make sense to, because you also have to consider the installation cost. Don't forget, chillers are costly, very costly. So you also have to take into consideration the capital cost involved. If you're building just a 30-bedded hotel, you don't want to invest in a chiller, right? Does that make sense?
Yes, sir. Actually, it is based on the convenience also. And if the hotel is not having any other lobby space or only a small reception and some 50 rooms, just like a lodge, then it makes sense for going for split AC, right, sir?
Right, exactly. It's application specific and budget of the client. Overall, if you see the running costs, it will be more or less not too much different in your real world. Sometimes what would happen is that because in bigger hotels you have that key card mechanism, the moment you remove the key card, the AC gets switched off. But if you have split AC, if somebody leaves the room, they might still leave the AC on and will keep running. Okay, those are the things that also can happen. Right, so it basically is application specific, and I would say in small hotels, it would obviously make sense to, because the budget is less, capital costs prohibit installation of chiller-based system. And anything more if you would like to add?
No, sir, it is clear. And nowadays, I have heard that in FCU, this fan coil unit, this BLDC technology has come. Is it available in the market?
I think BLDC motors had come a long back. It should definitely be available for fan coil units also. It should definitely be available. I think the air handling manufacturers, if you put them a request, then they will switch out the normal induction motor fan with BLDC motor.
Okay. I think tremendous savings can be also achieved.
Yes. Okay, one more question is, does ECBC specify any minimum COP for absorption systems? I think it does not specify in the KSECVC the minimum COP for absorption based systems. It only specifies for vapor compression based systems. Okay. Yes, a very good option. You can use VRF system also instead of chiller for 30 rooms. But again, VRF is also costlier than split AC. You also have to remember that. So not too much, but probably maybe 1.3 times that of split AC. But yes, VRF system can also definitely be installed. And of course, they have because these days you have inverter AC. If you're going for inverter split AC and VRF system, I think they are both going to cost out similarly. But if you have old split AC, then yeah, it will be slightly cheaper.
Sir, in case of VRV, the building is very high. It is a high-rise building, more than say 20 floors. Then is it advisable to go for VRF? Where will be placed the outdoor unit? If the outdoor unit is placed at the rooftop or something, will it be efficient that refrigeration circulation will reach the ground floor?
Yeah, so what will happen is you will have to add additional refrigerant inside the piping. Otherwise, you will not be able to, because it has to travel a longer length. Ideally, it is admissible, by default about, I think, 70 meters, if I remember correctly. By default, if it's 70 meters, I'm not very sure if it's 70 meters or feet, can't remember. But ideally, if you're saying it's a 20-floor building, and if you have to reach, if the outdoor unit is on the rooftop, obviously you will have to provide more refrigerant. It's called refrigerant charging in the piping itself, so that it can reach the ground floor. But yeah, the efficiency will definitely decrease.
Yeah, someone told that this outdoor unit can be installed somewhere in the middle floors or something by constructing a platform. Is it feasible, sir?
Yes, absolutely. It is feasible. That's just traditional. In the architecturally, it can be given. You can ask the architect to provide a platform and they can provide it, but architects generally tend to fray upon that, no, we are not going to no, my building should be aesthetically pleasing, so it can be a challenge, getting that platform
Yes.
built out. Yes, it can be done. Technically speaking, it can be done, but sometimes architects can be the boss, so yeah, you'll have to talk to them.
We have to go for side discharge or something rather than top discharge. Side discharge unit is also nowadays available. No?
Sorry, could you repeat that?
Yeah, so otherwise we can go for side discharge rather than top discharge. Side discharge unit, outdoor unit also available no? in VRV.
Right. Yes. Yes, you can do that also, absolutely. But I think the side discharge units are slightly costlier, if I remember correctly. But yes, you can also go for that. Okay, so maybe just for everyone else, when we are talking about variable refrigerant flow VRF system, it's again like a packaged unit itself. It's just that the flow can be varied for the supply and return fans, and also of course the refrigerant itself. It can be controlled. The compressor is variable speed, and by having variable speed we actually save energy. So what happens is, if I go back here, now all of these, you see, all of these are induction motors. Okay, you have fan, air handlers, which is again an induction motor. The pumps, induction motors, and the compressor itself is an induction motor itself, and you have the condenser water pumps, and of course the cooling tower fans. Okay, so all of these are induction motors, and these can be controlled. If you control the speed of these, because your load is not always constant, as we are talking some time back, hot water, the heat loads. Okay, when we're talking some time back, the heat load, as we're saying, that the heat load increases towards the evening, right? So in the morning, when there is no heat load, we can actually reduce the speed of these fans, and then if you reduce the speed of this fan, subsequently you reduce the speed of the pump, the chiller, and so on. So you start saving energy by putting variable speed drives over here on all these components. So there's something called as fan law, which says that if you decrease the speed by any amount, almost you save energy by to the power of 3 of that reduction. If you have reduced 10%, you save power 10% cubed. Okay, that much amount of power you will be saving if you reduce the speed by just 10%. Okay, so with that in mind, let's look at the split system. It's just fine, everything is split or package system. You model it as package single zone itself. As you see over here, you'll not find any system specifically called as split system. And if you wonder why is that, because technically the split system is kind of a package system itself. If you join the indoor unit and outdoor unit together, it will become a package system in itself. So there's just not much any difference in package system and split system. Okay. So that's that. And if you have VRF units also, you can use package single zone or maybe packaged variable volume or packaged multi-zone. Okay. Because what eCache does is here really it does not mimic the real world compressor accurately. So in real world, what will happen is your compressor will start and stop. But here the compressor will probably be reduced. The speed of the compressor will be reduced. It has an inbuilt equation in which it will just take as per the inbuilt equation. Okay, so let's look at let's just try to understand this screen what we have over here. So this is the system type we take for split AC or VRF. We take package single zone. For VRF, we also sometimes take packaged variable volume. Okay. After that, you have fans. So when we talk about fans, it is mainly, as you can see, supply and return fans. So supply fan is basically which is throwing air into your room, and return is it is picking up air from inside your room. In split AC, what happens is in your indoor unit itself, the same fan does both the work of supply as well as return. So it pulls air from within the space, passes it over the coils and throws it back again into the space. So if we look at this diagram over here, so you have this supply fan. Okay, this is your cooling coil. So you can see from cooling coil, it passes over the return fan. It goes over here. You see the return fan. If you can see the arrows, if you have economizer here, as you can see, these are all blank. We'll understand what all these are, but you can see supply fan and there's no return fan over here. So it is being circulated in a circular loop. Okay, and air cooled condenser is just it's just outside the system. So and there is a refrigerant circuit in between. So you have the air which is passing over the cooling coil and it is getting cooled, and then it is getting thrown into the space, and then again that same return air is just coming back into the space and again passing over the cooling coil. The cooling coil is connected to the condenser unit. Okay, so that's basically the work of fan. And as you can see over here, you have two main things. One is the static pressure drop. It's in inch of water gauge, and if I just right click and click on restore default, I get this kilowatt per CFM. So every fan, it will have every supply fan, what is the amount of air it can throw or it can supply every minute. Okay, so we call that as CFM, cubic feet per minute. And you also have this kilowatt, which is the electrical power. So the electrical power is the unit input and CFM is basically the output. So kilowatt per CFM, how much kilowatt does the fan need to send out 1 CFM? So that is what is being entered over here, and that is provided in all the fans. Okay, even if you have VRF indoor units, or this you will find only in indoor units. Okay, this is for the indoor units only, or air handling supply fans only. Okay, you can possibly search for any data sheet of an indoor unit. So even if you go for a split system, you will have one indoor unit, one outdoor unit. So the kilowatt or the power will always be for the indoor unit fan only. And don't take the entire, sometimes the manufacturers give the entire unit's power. They'll say 1 kilowatt. Okay, 1 kilowatt can definitely not be the power of a fan in case of a split unit. It will be approximately about 30-40 watts or something like that. So that's that, and you can also specify the flow parameters, whatever is the design CFM. So all these data you can find out in detail in the documents provided by the air conditioning designer. Okay, HVAC air conditioning consultant. And here you can see the fan control. You have constant volume and you have variable speed. Okay, so if you have a split AC, which is in inverter AC, I mean, you can change this to variable speed, and if it's a VRF also, change the fan control to VRF speed. So VRF can, or indoor unit can modulate the amount of airflow into the room. Yeah, you can possibly use the default values if you don't have the data, but that's something that you will have to ultimately put it in later when you proceed in the, when you reach the final construction submission stage. Initially, you can just assume, that's fine. These values these days, that is almost 0.5 watt per CFM, have already been reached in almost most of the fans or units. So yeah, you can go ahead and use these values, the default values. Then you have and yeah, the fan schedules. Okay, this is the fan schedule that we had seen earlier, on or off. Okay, so that's basically it. And outdoor air is generally not there. Split AC or VRF system, you really don't have outside air supply. You have to give separately from something called as TFA, treated fresh air unit. We'll look at that in some time. And these heat recovery and everything else will probably look in, after we study the water side a bit. Okay, the most important thing, as I was telling, is the COP. Under cooling, you have something called as unitary power. And under unitary power, you have something called as electric input ratio, cooling electric input ratio. So this is the inverse of COP. Okay, coefficient of performance at standard conditions. Okay, please remember standard conditions, standard test conditions. So for example, for a split AC, you get about 3.5 as your COP. Inverse that, you have 0.2857 as your electric input ratio. So you have to enter this value, 0.2857, over here. Right? And condenser, as you can see over here, by default, it is air cooled. The moment you switch it to water cooled, we'll not look at the other ones. The moment you switch at water cooled, it will ask you for the water cooled condenser circuit. You need to have a, as you can see on the top, right side, you have water cooled condenser. So you need to have a condenser water loop. CW stands for condenser water. Okay. Now, one of the few questions that you might have or you might encounter, let's say these 4 classrooms, number 1, number 2, number 3, number 4, are catered by a single VRF unit. How do we model that? We can't use 1, 2, 3, 4. These are like separate systems in itself. So what is happening is, you, in that case, you consider this a single one as your outdoor unit. And what I'm going to do now is put all the classrooms under the classroom 4 zone, HVAC system, sorry. So the parent HVAC system, I'll change that. Okay. Oops. Right. And the next thing that I need to do is delete these systems. Otherwise, it will throw up error. Okay. And let's make a single outdoor unit for the lab once. This will be 5, and I'll delete this. Similarly, the corridor is basically sum. Okay, we'll leave that as it is. And here. So I'll make this oops, it can copy and paste, so we'll have to do it one by one. And this will be J95, and we'll delete the other systems. Okay. And if I want to reduce, oops, there's one more here. We can also take this sum, can put this towards the end here and delete this system. Okay, so we have 4 outdoor units, and in fact, I think there was a question earlier in the day: what if in the labs these are double-heighted labs? What will be the case then? Okay, so in that case, what we'll do is we'll just reassign this system to the zone, to the parent system, and that's about it. Delete this system. So if you have this double-heighted ones, the same under the same system, just punch them up, and that should be it, really. Because at the end of the day, the heat loads will be the same on each different space. And of course, yeah, you can probably, let's say here, this is first floor. So in this space, you will have the lights, and in this space, you will have the occupants. So you have to really, accordingly make the occupancy over here to 0. Occupancy to 0. If it had been double-heighted spaces, both these labs, if they had been double-heighted, And here we'll remove the lighting. Yeah. Let's say this is 0. Yeah, because lights will be in the top, right? In a double heighted space, the light will be in the top one. And here again, there will be no equipment also. So equipment also will switch it to 0. Yeah, so this will be the case in which we have double heighted ones, right? Now let's save this. Okay, any questions until now? And the next thing item we'll take is the water side. If we change this to water cooled systems. Okay, so this is your typical VRF layout, and all you have to do now is for the outdoor unit, you will only enter the unitary power, and of course you can enter the cooling capacity also, which you will get from the data sheet. And for fans, you can just sum up all the fans, okay, all the indoor unit fans for each individual, that is 4321. Sum up all the fans, supply fan or indoor unit capacity. By capacity I mean the flow rates, and put it in here, the design CFM. Or you can also go to the zone individually and we can put in the design CFM over here, okay, and that's about it. And of course the cooling capacity also you can put over here, the maximum cooling rate. So this will be each indoor unit, okay, indoor unit you have the cooling capacity and the flow rate, but the supply fan power you will enter here itself under fans. So this will be supply fan power. Okay, so the question was, can you please repeat why didn't you consider LPD for double heighted spaces? So for double heighted spaces, I considered LPD, but only on the top floor. Okay, so if I look at here, so this is okay. So in lab 1, I considered the LPD only in the top floor, because in double heighted spaces, obviously you will have hanging lights which will be high above, okay, and they will not reach the ground floor. Imagine you are in a double heighted space. Where will the lights be? It will be obviously on the top and not on the bottom. So that is why we removed the LPD from the bottom one. Okay, I made this as 0 and I left the top one as is. In writing, I left it as is. So is that clear? Okay, right. So repeating once again, for a VRF unit under fans, you will put in you will sum up all the indoor units fan power and divide it by the CFM, and you'll put that here, and you will also put the flow parameters of all the indoor units. And for the outdoor unit, the only thing that you need to put is the COP. That's that. And specific within the zone, you can put in the CFM and the cooling capacity of the indoor unit. And for the outdoor unit also, of course, you can put in the total cooling capacity over here under cooling, the total cooling capacity. If you don't have those details in the starting, you can leave it blank. That's perfectly fine, no problem. But when you go get those details, you can always put that in. Okay, to Sandy's question, in that case, do we need more LPD to achieve the same lux level in GFL? That's up to the designer, the lighting consultant. What kind of light fixtures have to be put in, and that detail can be provided by the lighting consultant, because you have to determine based on different lux level requirements for different types of spaces. Because it's a lab, obviously your light levels requirement are higher, so yes, you will have to probably go for a higher LPD. So that's the answer to Satya's question. And then you have is EIR reciprocal of COP? Yeah, EIR is reciprocal of COP. Okay. Now very quickly, let's switch to central plants. Okay. So to make central plants, all you have to do is change the system type from package single zone or package variable volume to variable air volume. It will straight away ask for a CSW loop, which you can create from library, starting points and default CSW. You can choose starting points and default CSW and click on OK and click on done. The same thing you do for all the systems. Okay. You make it variable air volume, and once you have already made that loop, leave that loop, choose that same loop. Don't make another loop. Volume and default CSW. Done. So what's happening here is a single air handler is supplying to all these zones, and in this case, as you can see, under cooling, the unitary power will no longer be available, because the compressor is no longer here. The compressor has shifted to the chiller. Right, in package systems, the compressor was there in the air side. Okay, but when it comes to water cooled system, the compressor has shifted to this side, which is basically the chiller over here. Right now we don't have a chiller, we just have a loop. So we need to create a chiller over here. I right click, create chiller. Now in chiller type, you can, as you can see, there was a question earlier, can we model VAM? So this is one stage vapor absorption and two stage vapor absorption, gas absorption. So these are the three types of, and even engine driven you can have. These are the vapor absorption machines, VAM, which you can model. Otherwise, these are the electric ones, or the normal ones which run by electricity. So let's take electric screw and click on OK. It asks for chilled water loop, which you have already made, which is the default CSW, and then the condenser type. If you have air cooled chillers, you'll select air cooled. If not, you'll select water cooled and click on done. It will ask you to define the condenser water loop. You can go to library, and here you can select default CW, which stands for condenser water, and click on OK. So as you can see, it is created. Here you can see the variable air volume systems on the right. Then you have the blue one, and of course, yeah, one more thing. In typical HVAC systems, blue represent cold and red represents hot. So now you have this is the water circuit, and then it goes to the chiller, which houses the compressor. And you can see the electric input ratio is transferred to here, right? And then if you create a condenser water loop, then you need to create a cooling tower, which is nothing but a heat rejection. So we'll say open tower. We'll ask for the condenser water loop and click on done. Right, so that is a chiller based system. Okay, that's how you create. Yeah, sure. The first and foremost thing that you must do if you want to create a chiller is change the type of system from package single zone or package variable volume to package variable to variable air volume system, and then immediately it will ask you to select a chilled water loop, which you can if there is no chilled water loop, you can create one, and that will be named as default CSW and will be selected here. After that, you go to water side system and you right click and create a chiller. The chiller you can either create from scratch, in which case you have these options, or you can just copy if you already have a chiller. You can also change the type of chiller from inside here. You change it to one stage or two stage absorption. The moment you change it to one stage absorption, let's say, it will ask you for a hot water loop because it needs heat. So you select library and then default HW. So remember, HW is hot water for space heating and DSW is domestic hot water. There are two different types of hot water loops over here. DSW stands for domestic hot water, which is specifically for laundry and all those purposes. Okay, let me just a second. Yeah, there you go. Okay, as you can see, this is in bright red color. This hot line, and here you need to create a boiler. Okay, so that's how you create the chiller, and of course the COP will in this case you will actually give the heat input ratio instead of the electric input ratio. So there is a small amount of electricity that is required for some minor pumps, but as you can see, it's very low. The electricity requirement in absorption chiller is very, very, very insignificant and very low. Okay. And anything else that I'm missing? Okay, that's that. Okay. So sometimes what happens is that chillers can also have their own primary pumps. So over here, what you see is basically this is a secondary loop. Okay. There's something called as primary chilled water loop, and there's something called a secondary chilled water loop. So primary chilled water loop is basically for circulation of water within the chillers itself, and secondary circulation loop is for transfer of water to the air handling units. So chilled water loops are further subdivided into primary and secondary. So if you have primary secondary configuration, the default CSW pump, the CSW loop here you'll have to define a primary CSW loop, which you can just CSW, I'll say primary. Okay. So here you have created two separate. One is primary and there is secondary loop. Okay. So this is the primary loop, and then you have secondary loop. This should be actually this should be the other way around. This is primary. Oops. Over here, and this is actually secondary. Yeah. Yeah. Oops. I think this is going to crash. Yeah. Right. Yeah, just once again, I'll explain what is the role of primary and secondary loop. So as you can see, this in this diagram itself, you need every chiller needs some minimum amount of water. Okay, you can't send water directly. You can't have direct water, all the water flowing over here. So within this circuit, within over here, there'll be another circuit, which is basically supplying water to the chillers, mainly to the chillers. Okay, so that is primary. We call that as primary chilled water loop. And then the secondary is basically the distribution, for the distribution. What you see over here, what I have written over here is chilled water distribution pump or secondary pump. So this is the secondary, the distribution, which is taking it to the upper floors, okay, or to the air handlers. That is called as secondary loop. The primary loop is always in the chiller side. Okay. Which was our project. The primary secondary pumps is irrespective of where the location of the chiller. The main goal of primary circuit or primary chilled water loop is freeze prevention. You see the temperature over here, if you see, is 7 degrees Celsius. Okay, the return water is at 7 degrees Celsius. If you have the refrigerant as well as the chilled water over here, imagine if this temperature drops down to 4 degrees Celsius, what is going to happen to water? We'll have freezing. Okay, ice will start freezing, and if you have red, that ice expands. Okay, so what you will have is you'll have pipelines bursting. So just to prevent that, most of the time, if your control systems, this is mostly in older types of system these days, because the control circuits are such good that they can always maintain the temperature at 7 degrees Celsius. They can maintain the flow of the water. Okay, so that is one of the reasons why primary circuit was being provided earlier, to have a minimum flow to the chillers, so as to prevent freezing or ice formation or bursting of pipes. Okay. So I think this is still at, I think the last changes that we made was lost. So we can, I think we can quickly relook at this. Default CSW done. Variable air volume done. Variable air volume done. Right, and then we go here, create a chiller type electric screw, click on OK. CSW condenser type is water cooled. We select default CW, click on OK, and click on done. And then we also have create heat rejection for the cooling tower. Click on OK, and we select the cooling tower. Click on OK, and that's that. Let me save this. Okay. So this CSW pump right now is acting both as primary and secondary. So if you have to create another pump, just click on here. I think that'll be loop attachments. Yeah, for chilled water. This is, you can create another primary pump. And that's it. Our main intention is to create the pumps, because pumps are the major power guzzlers in the primary circuit. Okay, so this is primary and this is your secondary CSW pump, just so you are clear. Okay, so secondary CSW pump, which is the distribution pump, and this is the chiller. Within the chiller itself, it is supplying water. Okay, and here you can see this changes to chilled water part. Very good question. In pumps, there are two major inputs. One is the pump power, and in kilowatt, and your GPM, gallons per minute, the flow rate. So flow rate and pump power, those are the two critical inputs. And if there is a variable speed drive attached on the pumps, in the primary, ideally they do not attach any VST. You understand why? I just told you the reason. We can't have small amount of water flowing through, otherwise that will freeze, lead to bursting of pipes. So in secondary, we can have variable speed drive pump. Okay, so these days the primary can act as secondary because we have very good control systems, but don't be surprised if they give a secondary pump and a primary pump separately. Okay. And for heat rejection, of course, the electric input ratio is in fact the ideally this kilowatt should be enabled. I think the moment you give this capacity, let's say one, I think this will be enabled. Yeah, the moment you give the capacity, the fan kilowatt per cell will be enabled, and you can enter that value. This will be provided by the HVAC designer. So now I will show this. Okay, and you can also provide variable speed drive over here. If the cooling tower has variable speed drive, you put it here, variable speed fan. So the fan can rotate in at variable speed. And that's about it. As you can see, chiller specified at rated conditions. So always selected the rated conditions, not the design conditions. So the COP that you give or the electric input ratio will be at rated conditions. Okay, so any queries? Yeah, please feel free to ask.
Sir, I'm basically from electrical background, so HVAC I'm not very familiar. So this is a very basic doubt. So as you told, there are two absorption mode and compression mode for chillers. So does the absorption mode uses hot water loops and the compression mode uses chilled water? Is it so?
No, when we have vapor compression machine, the major input is electricity. When we have vapor absorption machine, the major input is heat.
So this hot water loops comes with absorption units?
Yes, when you have absorption chiller, you have to provide a source of heat. So hot water loop in this case.
And in compression, we will have this cooling towers and all.
Yeah, in vapor compression and vapor absorption, both we will have cooling towers.
Okay, okay. And this chiller unit is with compression, is it so?
Yes, this one is compression because here you can see it is clearly written, as you can see, electric. Okay, so electric is the major, and the moment you go for absorption, it needs a hot water input.
Okay, sir. Thank you.
Okay. Any other thing that I missed? Maybe, let's see. Okay, I think that someone asked me a question regarding hot water calculation. What exactly you wanted to know? I think it was asked privately. Let me just copy paste that. Oops. Okay, this was a question asked. Please explain about hot water calculation and adequate in eQuest. So if it is specifically about, are you asking about space heating or are you asking about domestic hot water? So that is my question. If it is space heating, all you have to do is create boiler, and this will be a hot water boiler or steam boiler or whatever it is you want. And you can click OK, hot water loop. Okay, done. And in air side, you have to select the heating as hot water coils. Over here, you have to select hot water loop. Yeah. So only then will this be connected, the loop on the left side. and onto the right side. So it's a request that please ask in the public chat instead of asking privately. Another. Okay, so they have replied in case of a domestic hot water for ECBC hotel, building or hospital. Okay, so for that, so this is what we have. You have to create a domestic hot water heater. Choose the type, electricity, most cases. And this is DSW, domestic hot water. And as you can see, how much is recirculated flow and how much is the process flow. So recirculation flow is just the minimum amount of water that we need. So let's say 0.5 GPM and maybe 10 GPM is the process flow. And you have to select a schedule and you're done. So here is the heater that is calculated over here. And specific to ECBC, what it asks is that you have to size. Now that sizing is completely given by your consultant, the MEP consultant. They will give you the size, the GPM will be given to you. So you have to enter that GPM over here. And that's it. Okay, so can you simulate heat pumps? Well, what would you mean by heat pumps? I'm assuming which can do both heating and cooling. Is that what you're referring to when you say heat pumps? Sandy? Yeah, okay. So that's what you're referring to. So let's see. That's basically, let's look at this one. So again, I'll select package single zone. Yeah, whenever you select package single zone, you have to select a control zone, which should be one of the zones within that particular system. So in this case, I can also select classroom 3, that's fine. So cooling and heating. Here under heating, you have to select heat pump. So need source will be heat pump. And as you can see, it becomes heat pump. Okay, so yes, you can simulate. The answer to that is yes, you can simulate heat pumps, which is basically providing both heating and cooling. Right, okay. Are we auto-sizing chiller as cooling output in MBTU per hour was not provided? If MBTU per hour was not provided, yes. Right now we are auto-sizing, but if you have the capacity in tons, then you can convert it into MBTU per hour and enter it here. The equivalent capacity can be entered here. Right now we are leaving it on auto-size. But in proposed case where all these data, whatever I told you, that is the capacity of the chiller, the pump power, flow rates, everything will be provided to you. Or in fact, you should be asking the client or the MEP consultant to give you all those data. Right? For a centralized heat pump connected parallel to CSW, not sure I understand, but yes, you can have that. Let's say this presently is on chilled water loop, and this one is a heat pump. So Yeah, you can have both simultaneously. Or you're saying the cooling should happen by chilled water. Yeah, you can do that also too. In heating, you can select heat pump, and there you go. Sorry, okay. The cooling. Okay, okay, I think that is a bit of a problem over there. Heat source you have to move, I think. Do they even have this kind of system? Not sure. I'll have to check where the cooling will be done by chilled water loop and the heating by just by heat pumps. No, I'm sorry. I think you're talking about water side economizer, are you? Where you do the heat recovery from CSW loop. Yeah, that's it. Yeah, you have to tell the exact terminology, otherwise it gets confusing. So yeah, that heat recovery you can do it over here. As I said, here's the heat recovery to default DSW. Right. So yeah, it can be done here. Yeah. There was one. Is there any standard calculations for finding out standard case domestic hot water parameters? I think NBC gives it as 20 liters per day for offices, but the MEP consultant should know about that. I think but it's specified in NBC. Okay, anything else? Any other questions? Okay, so can probably wind up today's session, and tomorrow we'll look at KSECBC, the requirements of KSECBC, and how we can model that in with eQuest. But yeah, I'm here for another 5-10 minutes. You can ask questions if you want.
Participants, any more queries? If no, we can wind up.
Yeah, sure. Absolutely. Um, 1 minute. Let's switch off the heat recovery. So if you have to create domestic hot water one more time, all you have to do is right click over here, create DW heater, and you can select the type. Most of the times it's electric heater, and you can create a DSW loop from library. Oops, not sure why it didn't take. Okay, DSW1. Okay, the loop recirculation flow, that's the minimum amount of flow that must go on so that the heater doesn't corrode. And this is the process, that is the GPM. So I'll give that in and click on done. Okay, not sure why it's stuck here. Okay, it has gone into an infinite loop. I'll have to restart this. But yeah, that's how you give one GPM and process flow, and then you have to give the schedule, and then you can create that domestic hot water heater. Probably have to kill the program.
So here we are in the detailed mode, right?
Yeah.
So if we want to change something in the wizard mode, like some project data or something, if we go back, will we lose all of these whatever we have created in the detailed mode?
Yes, you will. You will lose all the changes that you make.
Okay, so means we'll have to make perfect the wizard and then only move to detailed mode.
Yes, yes. Everything else you can actually. The only thing you must be worried is in the wizard mode is if this internal layout changes. Otherwise, everything else can be done in detailed mode. For example, if window sizes or anything change, you can always go to the window and change those sizes, and that should be okay. But if the space layout changes, then yeah, you will have to go back. Okay. Any questions? No, you can't. There's no such option available in eQuest to add custom made schedules to library. But what you enter in here in the schedule for cooling is basically the upper limit of that setback temperature for cooling, and if it is heating, then the lower limit of the heating setback temperature, because above that is all uncomfortable range. So design is whatever you want to design, and then plus or minus 2, which is your setback temperature. You can probably have it here. So for in this case, design was 75.2, and after setback it has 78.8. So that's what we have it. I'm not sure what you mean by equipment heat loads, but yes, the equipment auto sizes everything, as per the heat load within the space. That is why we have not entered any specific data over here. If you see under cooling, we have not entered the cooling capacity, so it will auto size everything based on the heat load, because which we have already provided the building shell and it loads we have already provided, and based on this the heat load of the space will be calculated, and the air, the only efficiency that we are entering is basically the COP under unitary power.
Under
Sorry, if you make continuous changes, this happens sometimes. So the unity power is disabled at the moment. Have to change this. Okay, this is a variable air volume system, that's why it is disabled. Not sure why it's showing heat pump over here. In reality, it is a variable air volume. Okay, here. Space equipment's heat load. Right, yeah. Yeah, those are, we have an input here, space equipment does 0.5 watt per square feet. So that is automatically taken. For that case, what we have specified is that the heating will actually never switch on, because in heating what we have specified is that the setback temperature is such low temperature that the heating equipment will never switch on. Does that answer your question?
Sir, actually, my question is that while in colder climate, where there are a lot of heating office equipment, say within an office space, and you have heating systems that tend to heat the atmosphere inside. So basically, we should not consider the heat generated by the office equipment, right? Because that is, in a way, we are designing the heating systems for lower loads. So we should not be considering the heat generation from the office equipment, right? So how do we make sure that while in heating mode, we are not considering the heat generated by the internal loads, such as office equipment.
Sorry, your voice was breaking, but what I could make out is that if you have a situation, let's say an office in Bangalore, where you require heating also, sometimes in winters you do need heating, so you don't want that heat load to be considered. Is that correct? During heating? My question is, why would you not want it considered? Maybe while designing the system, yes, there's something called as, heating design day, which you put it in the heating mix. For example, over here, you have STD, something called as STD. Anything, let's say internal loads. Yeah. So here we have heating design day, STD, where everything is set to 0. Everything is kind of set to 0. So that will be part of the design. But when everything is getting simulated, it will take into consideration the heat generated by the office equipment during the heating mode. If you want to, okay, great, okay.
Hello,
Hello.
am I audible? Thank you,
Yeah.
sir, for a well-organized session of the CQS simulation. Hope our participants will be better with understanding about this and will be able to practice for the same. Participants, thank you all for your valuable time, and we'll continue the remaining session tomorrow morning. A webinar link for the tomorrow section will be mailed to you within an hour, and the today's recording will be sent to the participant after the completion of the two-day webinar. Participants are requested to join for tomorrow remaining session, and for certificates they are to be for that to be given to those who are attending the full session today and tomorrow. So thank you, sir. Thank you, everyone. We are signing off for today, and guys, you can leave this meeting after.
Thank you so much. Have a great evening. Night. Thank you. Bye.
Thank you, sir.
Thank you, sir.